Okay, so I'm going to show the full custom portable kit for the 103-5 bearing. So we're going to start with the install tool. So we have a guide bushing. Guide bushing will go into the bearing housing hole, and then we'll go ahead and insert our bolt, and then we can draw our bearing through. You can see that it will help align the bearing. You can use a pusher, push the bearing into the hole if it wants to go. Or we can draw it in, nut. Okay, so we will, hopefully I have my Allen wrench. Draw the bearing about halfway in, and then you're going to remove the tool. Bearings about halfway in the housing. Remove your guide bushing. That bearing will now not gall the side of your aluminum housing, cause any damage. So you can go ahead and draw it in the rest of the way. You can see I actually can do it almost by hand. And then this installation base, once you draw it all the way in, you'll feel it bottom out, and that means that it's flush on one side of your housing to do your roller swedge. So that is the installation tool. Okay. And then we will go ahead and use, this is our Slimline portable swedging tool to get into tight clearances and whatnot. So we can go ahead and insert that in there. Check and make sure the rollers rotate. You should always check and make sure you have the right tool by checking the center line of staking and make sure it's in the center of the V groove. Okay, and we have a first side base which is flat. That's going to help keep the bearing flush on one side during the swedging. Insert that on. In the back side we have a thrust bearing that we're going to tighten the nut up against. So this, pretty simple, you're just going to tighten the nut, and then socket key. You can then roll the tool. You can actually roll it from either side. You could put a socket on this or a Allen key inside there. So depending on your clearance situation, if you had an obstruction where you can't use a wrench on one side, this tool is nice that you can actually roll it from both sides. So I'm holding pressure on this left side, tightening on the right side. And what I'm looking for here is that the rollers are actually rotating and not dragging. Dragging would cause galling. And then you can use a flashlight and actually see the lip gap in between the bearing and the chamfer. And our tools are well designed that you don't need to do too much rolling and tightening, because that bearing is almost all the way swedged over. I'm just going to go just a little bit more. You don't want it to go too much, otherwise you might over swedge the bearing. Okay, I'll go ahead and remove the tool. You can remove the tool and add the tool on as many times as you need to. So you don't have to do this all in one shot. That way you can keep an eye on your progress and not damage your bearing. Okay. And if you can see that, the bearing is swedged all the way into that chamfer already. So again, I've been doing this for a long time, so I know how it should feel when you're doing the portable roller swedging, but I was able to, in the first shot, get that 100% swedged, and our ball still moves, which is great if you have a low torque value you're going for. All right, so then we can go to the second side. So this side hasn't been swedged, this side's been swedged. So we're gonna take our tool and put it in the unswedged side, and then we're gonna go for our second side swedge base. So this has a matching angle, a 65-degree angle, that's gonna go into the swedge that we just created to keep that bearing from moving back and forth. Again, I'm gonna make sure my tool rotates nice and freely, it's seated correctly down there. I've got a thrust bearing on this side as well. Add the nut on there. I'm going to snug it by hand, make sure I'm still rotating. Okay, and then do the exact same thing. So now I've got the wrench on the other side. But again, I can tighten this, I can roll with this side if I want to. So this tool is unilateral, that you can roll it on either side depending on the clearances you need. Like that. Or if you want to, if you don't have room on the aircraft you're working on or on the part, you can roll on this side. I can feel it get tighter, and what that means is that the rollers are going to start digging into the chamfer. So that means that you're not going to be able to swedge it over much more. So you can definitely feel as you're tightening it that you're bottoming out that V-groove lip, probably right about there. I can feel it, it doesn't really want to go much more. And that means that that V-groove lip is all the way inside that chamfer. For good measure, just a tiny bit more, but again, I can feel it. I don't need to go any more than that. And that's going to be 100% swedge. Okay. I'm going to go ahead and remove it. Boom. Look at that. Swedge on both sides. Very important that the bearing is centered. Centered is a factor between your housing thickness and your bearing thickness, but we include a flattened second side swedge base, so you're able to make sure that if they are the same thickness, then your bearing will be centered. Okay, so our bearing's been swedged in there. We can go ahead and use our proof load tool. So here we have our Futech IH505, and then this is a custom load cell that we stock and we have manufactured by Futech to be able to proof load with. It's a 3,000 pound load cell. So basically all you need to do is just add your bolt onto your through your load cell. Then you have a proof load cup, and then you would take your proof load die. It'll say proof load on it, and then you would add on your nut, and you can tighten this whole assembly together to apply load one direction. You'd take a before and after measurement to then see if the bearing moved it or not, and you would do the same to the other side. Add your proof load die and your nut, apply load, and then on your digital readout, it'll say how many pounds force you're applying to that bearing, and you can see, again, with before and after measurement, if that bearing has moved or not. Then the last two tools we have are the portable cutting tool. So if you have a bearing that you had a bad swedge or you need to remove for whatever reason, you could use our portable cutting tool to cut the lip off the bearing, which is important because on soft aluminum housings, if you try to push that bearing straight out, you'll drag that lip and you'll oversize your hole, and you won't be able to use your part again. So we have a support die that's going to go on the back side, and we have what's called our guide rod, and you'll be able to put your nut on, and you would tighten your nut, hold your guide rod, tighten it. Now you have an axis on which your cutter can ride. So we have our cutters that we use, and the cutter has a spring on the back to control the pressure. You would increase that spring pressure as you start to rotate your cutter, and then once you get to the bottom of the V-groove, so only about, on this bearing, it's about 25 to 30 thousandths. Once you get to that bottom, that's all you need to, that's as far as you need to go. You can go ahead and remove your cutter, remove the cutter assembly, and then you're ready to push that out. So you can use the removal die, it says removal on it. You can use that with a removal cup, which was what we used to proof load with. So you would take your bolt, removal cup. On the side that's still swedged, you would add your cup. On the side that you just cut with the portable cutter, you would add your pusher. You want to push the cut side out, and then we would go ahead and add our nut on, and we would just tighten this, and it will draw the bearing through, and the V-groove will crack in on itself and allow you to pull it all the way out of the housing, being able to reuse the housing. So that is our full portable kit, which for this one we're just exhibiting the custom Slimline swedging tool, which what makes it a Slimline is the diameter is much smaller. So on this tool, our stock standard tool and the industry standard is about 1.25 inches, so about there. But our Slimline, we were able to go down to 0.852. So again, significantly smaller, and the advantage of that is you can fit into much smaller spaces. So if your part was at an angle like this, you wouldn't be able to get a standard tool in there. But with this one, you're able to get in there and you're able to swedge your part with plenty of room. So that's what is unique about this tool and makes it very important in working on the wing of an aircraft or an aerospace. All right, thank you.